Hello, and welcome to your second video on building materials for your introduction to Civil 115. And today I want to talk about non-conventional building materials. So let's first define what a conventional building material is. And we talked about concrete, steel, and timber as very common in the United States. A fourth material that I didn't mention in the last video because it's not that common on the West Coast, but is pretty common on the East Coast and in the South, would be bricks. It's also a really common material worldwide, and we can actually see the oldest U.S. brick building in the picture there in the upper right. Now, when we think about bricks in the United States, we would call it more of a masonry construction, and a more modern masonry method would also be concrete masonry units or cinder blocks as far as designing. But bricks themselves, just your red standard bricks, are going to be seen all throughout the world. They're really common in Europe, England, that area. They're also going to be really common in Asia, Nepal, India, and then you're going to see them also down in South America and parts of Africa. So here's an example of bricks in Nepal, and this is a beautiful building. I took this photo while I was with some students on a senior design project there in Nepal. In a less affluent neighborhood, we saw buildings that were more like this, and this was actually a little bit more common in what you're going to see. And one of the challenges with brick building is that it's very hard to make it earthquake safe, and so even though these are being used all around the world, they're buildings that also collapse very easily during a major seismic event, and they saw that pretty dramatically in Nepal and tragically. And another problem with bricks, even though they're so common, is that they actually have a very heavy environmental footprint. So the sky in this photo is not gray because of clouds. Here's another photo taken the same day. The sky is gray because of the pollution. Now, from the road here, we actually see a brick facility, a brick making facility, and the road was lined with these on either side. Even way off in the distance here, you can see the chimney of a brick firing kiln. And then, of course, as we zoom in a little bit, here's the kiln chimney for the nearby brick making facility. I don't even want to get into the other issues with this as we look at the truck that was delivering bricks from the kiln to stack in these piles, and we have the child labor that's happening. But the air quality in Kathmandu was so bad that the majority of people would wear masks. And there's really two major contributors. One, it's these kilns, and they're firing them like crazy to rebuild Nepal. And then the second is not having catalytic converters on their cars. But it begs the question, why, when we know these methods are not really that safe for earthquakes, and why, when they have such an environmental footprint, is the building with bricks still so prevalent across the world? And when I say that they have an environmental footprint, when we look at their carbon equivalent per kilogram of product, it's actually pushing 3 times that of concrete, and a brick building has a similar mass to a concrete building. So you're getting 2 to 3 times the carbon, and actually 2 to 3 times the embodied energy that you might get in an equivalent concrete building. Now, just for fun, I might put out to you that really it's the 3 little pigs' fault. And even more so, it's the 3rd pig's fault. Now, what on earth would I say this for? That climate change, or at least the prevalence of bricks, is all blamed on the pigs? Well, let's remind ourselves of this story. So 3 pigs got sent out on their way, and they needed to build homes so that they stayed protected from the winter. The first pig was described as lazy, wanting to just play and enjoy the flowers, so very quickly built himself a shanty house out of straw. The second pig did a little bit better, but also not the most industrious, and built himself a house of wood. Now, I would argue that's more of a shack and not really a house of wood, and certainly not using what we would consider good building techniques for wood. But the fable goes on to describe the 3rd brother as the hard-working, industrious, smarter pig who built a house using kiln-fired bricks and a cement-based mortar. Well, as the story continues, a wolf comes to try to eat the pigs. The first pig hides in his house. The wolf says, "Oh, I can get you, and I will huff and puff and blow your house down." And sure enough, the straw house, gone. So the pig runs off to his brother in the wood house. Back comes the wolf. Wolf says, I can huff and puff and blow this house down. And unfortunately, the second pig did not follow any of the hurricane guidelines for how to do connections that we have established in our building codes. And so his house also blew down. And so they raced off to the brick home and were saved because, of course, the wolf could not blow down this solid, sturdy, safe home. And even add insult to injury, they tricked the wolf into climbing down the chimney to come get them, but they had a pot of boiling water at the bottom. And so then they ate the wolf for dinner. So you get a warm, safe home and you get a warm, nice meal to go with it. And this fable was first published in the late 1800s. And it really does beg the question, did it have effect on people's thought process that started planting the seeds when they were young, that if you wanted a safe house, if you were smart, if you were hardworking, brick was the way to go? We'll never know, but it does beg the question of whether or not the author worked for the lime and cement industry. But, I jest a bit there because, really, how rational is a straw house? It's not like you could build a church in 1928 and have it still standing this time that's built out of straw, or a 107-year-old home that's built out of straw bale in Nebraska. This wouldn't be possible, right? Well, maybe it is if you use Nebraska Style straw bale construction. When settlers first started arriving on the plains, you didn't have options to build out of wood. There weren't enough trees, and so prior to the Industrial Revolution, shipping logs, the very sustainable method from the New England, they actually stacked straw bales. You got phenomenal insulation. You could just use a small amount of wood for your roof, your ceilings, your doors and window opening, but the majority of your load-bearing structure was this stacked straw bale. You would add a lath and plaster or a plaster to the outside, and that plaster would bond really well with the edges of straw sticking out of the bale and create a composite structure that was very durable and has been around for over 100 years. This has been modified in something called the post and beam method, where you actually build with post and beams of wood and use the straw bale as infill to give you your insulation and your wall material. And thanks to work done at Santa Clara University, this is actually in the California building codes as a legal way to build a residence in the United States. They can be multi-story. They're all around the world. You get great sound and noise insulation from these straw bale houses. So it's kind of a cool idea. So maybe the first pig wasn't that crazy. But what does that mean about the second pig? Well, this particular method of construction we see doesn't match what we would consider nice square or rectangular finished lumber. And in fact, looking at how challenging it is to connect those round pieces together might actually tell us why the next traditional or non-conventional building material I want to mention hasn't necessarily gone viral worldwide, and that's going to be bamboo. Bamboo's been a building material for 1,000 years. It's so sustainable. Bamboo is a grass. You cut it, it regrows like your front lawn. And so you don't kill it when you cut it down like you do with a tree. Furthermore, it's only 4 years between harvests, and you can get a lot more building material from 1 acre of a plantation of bamboo than you can from a forest of trees. The challenge are the connections, but if you can figure that out, you get really neat structures, whether it's ultra modern or rather tropical. And with these tropical structures, it is the challenge to connect, so you could also create almost a bamboo, or a plywood with the bamboo, like an oriented strand board where you use chips of the bamboo, you glue it together, you create a plywood, and then from that plywood you can create generic shapes that we're used to for building our trusses, our rectangular beams, to make it more acceptable and mainstream. Santa Clara students did just this in 2013 and created natural bamboo I-beams that they were able to test and get approved to replace a standard wood I-beam for use in the 2013 Santa Clara Solar Decathlon home. And just for fun, if you want to go crazy, you can spend a lot of money on a bamboo bicycle or from Santa Cruz dirt bikes. So with bamboo being such a green material, and straw bale, actually, we know it's working. What was the driver that really pushed brick so hard? It's hard to say. It's relatively easy to build with, and it's perhaps the fact that predating firing bricks and using them, we were already creating houses in a similar method using something called Adobe. So Adobe is an earthen structure. We use clay, sand, and straw. You might add a little cement. It's mixed together, it's formed into brick shapes and molds, but then it's just left out to air dry, so it has really a very low environmental footprint. And then you can see the house in the back. You build with it like you would with a regular masonry. In fact, earthen building is really the original building method, and it predates all of our other methods of building, even Roman concrete. And today, still, about 30% of the world's population live in homes made of earth. Now, often, instead of leaving the adobe exposed, you might cover it with a lath and plaster. Here's a very traditional southwestern adobe. Here's a modern take on the southwest adobe. But you can also go ultra-modern, like the picture in the upper right. Adobe is an absolutely viable multi-story building material, and there are ways to make it earthquake safe, but it's a second step that you have to learn how to do. Predating Adobe is one of my favorite rammed earth, just for its pure beauty. So the way rammed earth works is you have formwork that you build, and you put loose soil in between, typically a clay, sand, gravel. You can add cement, and then you come back and you tamp it down really hard. Initially, this was all done manually. Today, you do it with a pneumatic tamper. And in California, there have been engineers who have gotten rammed earth approved for building. There are structures up in Napa Valley, and you add steel reinforcing bar and cement into the mix. But you can get these beautiful layers. And this is so old that even sections of the Great Wall of China are built from rammed earth. And the beauty that you get inside of a structure is really undeniable. The very thick walls giving you great sound insulation, and the natural products really making the air quality in the building quite high. Now, rammed earth takes a lot of effort and is very physical. A still physical but less skilled physical method of earth building that's been around for 1,000 years is cob. Now, cob houses sometimes tend to be fun and organic and whimsical, or they can be just a plain house. But you're basically taking clay, sand, and straw, and you're mixing it together with your feet. You could have a horse or an animal walk on it. You could use a machine. But then manually, you just take clumps of this, almost like the size of a loaf of bread, and you can see the people there pulling out loaves or cobs. And then you slap it down on a wall and slowly build up a wall, being careful to compact the layers together. In 2018, our senior design students worked with the Cob Research Institute, and we tested cob walls here at Santa Clara University, and there has been movement towards getting now cob again into the residential California building codes. And it's important to note, when doing testing, everybody's wearing their protective equipment. Now with cob, you can also build inside, creating really fun organic shapes. And I mentioned before that cob's been around for at least 1,000 years, and that's definitely the case in England, where you have many two-story cob homes. And in fact, in southwest England, there's over 70,000 cob structures, some of them 300 to 400 years old. So it's obviously durable if built correctly. So I hope you enjoyed your first introduction to non-conventional building materials. These are not all that's out there. There are more to investigate. And in 115, we're going to have a chance to look at these materials. We want to talk about opportunities that exist in natural building and potentials for getting these building materials into our building codes. We're fortunate in the Bay Area to have a group of architects and engineers, the Ecological Builders Network, that is always pushing these natural methods forward. But it's important that we discuss what are the challenges and barriers that make it hard to get these into the code, and maybe importantly hard. So I hope you enjoyed your introduction. Thanks so much for listening.